Hello and welcome to a Keysmash tutorial on Race AI. We just finished up a series on Waypoint patrolling AI, and the two are not entirely separate, so if you haven't watched that, I'd recommend that you go back and watch that. We're going to be grabbing a few things from that AI, but I will go over everything that we need to use from that AI and how to program it in this video if you don't want to go back and watch the other one. As always, if you find these videos helpful, please remember to like, comment, subscribe, all that jazz. It really does help us out, and we'll hop right into it. Alright, so off scene, I have made a race scene, and the way that I've done that is I've actually used Photoshop. This is just a race. It doesn't really matter what pattern it's in. This was just a quick little racetrack that I drew. So in Photoshop, I created this racetrack, and I put little arrows and a starting point in the AI so you could see what I was planning on doing. The AI have to obviously start from behind this line here. Let's make this a little smaller. Behind this line here, they have to start behind that, and they have to make it all the way around the racetrack and back to the line. And that's great though. We can probably do that with a Waypoint AI, but we need it to function like Race AI would. So there's quite a few things that we'll need from Race AI that Waypoint AI don't have, and vice versa. There's a few things on Waypoint AI that Race AI don't need. So the first thing I want to talk about are the waypoints. So I'm planning on putting on waypoints like this around the track. You'll notice for each waypoint section there are 3 waypoints, and I'll talk about that in a second. But all of these little red dots around the various track represent, each cluster of 3 represents a single waypoint. If we were to take our waypoint AI we did in our last series and use that on this racetrack, we would find that we could get the AI to go all the way around the racetrack and just continually loop. And that's great because that's a base functionality that we need. But the thing about race games that's a little bit different is we need them to be dynamic and fun for the player. And the way that we do that is through a thing called rubber banding. You'll see that I've labeled this layer rubber banding, but we need to control the AI speed so that the player always feels like they're in a race. And there's quite a few ways to do this, probably the most infamous being the Mario bullet. If you're in Mario Kart or any of the various Mario racing games and you're in last place, you're very likely, when you get an item, for it to be a bullet, and that bullet just takes you up and drops you right in the middle of 6th place. But like I said, I use the word infamous for a reason. It doesn't feel very good to the rest of the players if you're playing with other people and various things. So how do we implement a style of movement such that the player gets that similar effect without knowing it, but still gets the fun aspect of always being in the middle of the race? Because that's what's actually ultimately fun for the player, when they're trying to drive faster and hit their turns right so that they're always having fun and they're close in the race and all that jazz. And one of the ways that we're going to do it are with these 3 dots on our race. You'll notice that for every waypoint section, there's an inside, a middle, and an outside track. Now, they don't have to be this far apart. I was just putting them this far apart for illustrative purposes. But we can control which waypoint the various AI go to based on their position in the race. So a slower car that's trying to catch up to the pack can go on the most inside track and take the most quote-unquote racing-worthy track around a race track. So you're coming from trying to cut all the corners, you're coming along and taking the most advanced track that you can take to cut off the most amount of time because they are behind in the race. And that way, as the race progresses, the people in the back are traveling a shorter distance than the people in the front, and the people in the front are traveling a longer distance than the people in the back because the people in the front take the most long way around the track. And that creates a big clump of race cars, and they're always swapping in and out on position, right? That's one of the aspects that we want. We don't just want, well, you know, this AI is going to be a little bit faster than that AI, so when we race 10 times, AI 1 is going to win 10 times. We want our race AI to work so that if we have 8 AI and we race 10 times, 4 or 5 of them may win. If you notice, a lot of old racing games won't necessarily use this method, and they'll always just kind of like have one car that's a little bit faster. That's very frustrating as a player. So when we have like various entities winning, that's a really good thing. So let's cover all this up and talk about rubber banding. So let's assume we have 8 AI in the player, so that's a total of 9 places. In places 1 through 3, whether it's the player or the AI, our AI will have the slowest agent speed. That's another thing that we can do to increase this rubber banding effect. We can make the players in the front travel a little bit slower than the players in the back, and the further back you are, the more you speed up trying to catch up to the pack. Obviously, we have speed versus the player. If all 8 AI are way ahead of the player, then we slow down all 8 AI so the player has a chance to catch up. As soon as the player does catch up, it resets normal. If the player's ahead, then we speed up all 8 AI. And the players and the AI that are in the first through third places will take the most outside waypoints. Place 4 through 6 goes sort of middle of the road, and place 7 through 9 goes on the most inside, and they're the fastest AI agent speed. So that way, when we're racing, everything's clumped up together, and the player's having a good time, and they're in the race, and we can control the race to create a dynamic thing. So let's talk about how we're going to go about doing this. This is probably going to require quite a bit more organization on the side, but that's okay. We're going to get started on the code today, but we will not finish this AI code. This is a lot of AI code. It'll probably be drawn out over 3 or 4 episodes. So let's go ahead and go into our assets thing, and we are going to create a new C# script called race AI. Now that we're in here, just like before, I like to delete everything. Just a personal preference here. We need to go over a few variables that we'll need to have. So we are going to need some serialized fields. If you haven't heard me talk about serialized fields before, they're just almost another way to make a public variable so you can see it within the editor. But it is allowed to be private. And it's just a little bit more secure. It doesn't really matter, but it is my preference to use them. So we are going to make some arrays of these waypoints. So we're going to call this an array of game objects, and we're going to call this outside waypoints. And we're actually just pretty much going to copy this because we have to have this 3 times over. So we have our middle waypoints and we have our inside waypoints. We need to have a list or an array of all of these waypoints together. Whether we are on our race and we're going to all of the inside waypoints here, let's pull this back up. Whether we're going to all of the inside waypoints or the outside waypoints, we won't know where we're going throughout the entire race. So there's a chance that you're in first place at some point of the race. There's a chance you're in 7th place at some point of the race. So we need to have the AI know exactly where they are for some parts of the race, and other parts of the race, they need to be on a different set of waypoints. So each AI needs to know where every single waypoint is, whether it's middle, inside, or outside. Additionally, we also need an array of all the other AI. So we'll make a private, make a private nav mesh agent. Well, that's not. And if you come across this where it says you don't have this nav mesh agent, you can just hover over it and hit Control period, and we'll see that we're missing the using Unity Engine.ai, and that's just up here. And you'll notice in all of our other ones, we have that same one. So those are our arrays that we'll need to know for the thing. So like I said before, I really like keeping my arrays and my regular private variables there just for the script separate. So these are our non-array variables. So what do we need to keep track of on this particular thing? So the only thing we've really mentioned thus far that we need to keep track of outside of our AI is that we need to keep track of our place in the race. So we need to keep track of our race position, and each AI is going to have their own position relative to the player. And each AI is going to have their own position, and it's going to save it relative to the script. So this needs to be a private int outside of all of the public stuff that we can see elsewhere. So we just have our private int position, and we'll go over how to calculate that position probably next week. It seems like it's a really simple thing, but honestly, calculating position in a race is probably the most complicated part of this entire little series for Race AI. But we'll go over how to calculate that tomorrow. All right, we'll go over how to calculate that next week. For now, we're going to talk about what we need to instantiate at the start. So if we take a look back at our original patrolling script, so this was without, anything fancy. This was just, if we see the player, we attack the player. If we don't see the player, we don't attack the player. We have a bunch of waypoints that our AI goes through in this script. And when we come through and we iterate, that's right here. So all this says is when the current position of the AI gets to its waypoint, and that waypoint's distance is, the distance between the two is less than 2, then we go to the next point in our AI list. So that's what this iterate function is, and that's what this iterate function does here. So if you've watched that video, this is going to be a little bit of repetition, but basically we say if we're not at the last point in our waypoint list, we go up to the next waypoint, and we set that as the destination down here, and we go. If we are at the end of our waypoint list, meaning that we're at the very end, we set it back to the start, and we set our destination and go. So let's go ahead and try to get this exact thing into our next function. So we don't actually need to keep this. I'm just going to put it down here for reference sake. So I'm going to select everything and hit Control K, Control C, and it just comments out the entire function. So we have our function here that we're going to be using. It's going to be called the iterate function, just like before. And I forgot one slight thing. We also need to have a private call to our agent. So we just need to have a private nav mesh agent called agent. And we'll put that here. And in our start, we'll instantiate that to be agent is equal to this get component nav mesh agent. So basically, we're saying whatever this script is attached to, we're just grabbing the nav mesh agent of that and setting that as the agent variable. Whatever this script is attached to, we're going to grab the nav mesh agent component of that, and we're going to set that equal to our private variable of agent. So, back down here in our iterate function, we need to first determine our position. So we need a series of if-else statements. So if our position is, and we need to do some sort of funky math here. So we have positions 1 through 9. We know we're going to have 8 AI, and we're going to have our player as well. So if our position is less than or equal to 3, we need to do some code here. Else if our position is less than or equal to 6, so this will only happen if it fails positions 1, 2, or 3. So this will give us 4, 5, or 6. So if that position is less than 6 but greater than 3, we will do some code there. And then finally, we just need our last else. It's always safer to do a full else here, just as like a little catch. So if your position 7, 8, or 9, we'll function some code here. So we've worked our position into our iterate function. So if we're in the first position, and we look back at our Photoshop file here, we say if we're in place 1 through 3, then we do the most outside waypoints. So we know we're going for our most outside waypoint. If we come down here to our former iterate function, we were just setting our current point in that waypoint. So in this function, we used current point to set our destination of the whole group of waypoints point. But in this race AI, we have 3 different waypoints, so we need to do something similar, but we need to iterate that for the outside, the inside, or the middle waypoints. So what do we need? We need a private int current point. Just like before, we're still going to have the same current point. There's still going to be the same number of base waypoints on this thing. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 13 different waypoint clusters. And it doesn't really matter whether you're going to the inside or the outside for this current point variable, because whether or not you go to the inside or the outside, your next point, your current point, iterates up, and you can only get to 13 whether or not you stay on the inside track the whole time, or you stay on the outside track the whole time, or you swap back and forth. So we need this current point thing, and obviously we need to set our current point to index 0 at the start because we're going through arrays. So our current point is set to 0. So the first thing we're going to do here, if we're looking at our position and we're trying to get to the most outside waypoint, is we're going to set our agent destination. So we're going to say our agent.destination. And then rather than do this at the bottom like we did last time, we're going to set this for each of these individual things. So we're going to say our agent.destination is equal to not points, because that's the array in our last one, but we're going for the most outside waypoints because we're in place 1 through 3. We're saying outside waypoints, giving it the, we're going to say our array outside waypoints, and we're going to give it the variable of our current point. So we'll say current points in there, and specifically that just gives it a game object. So we need to grab it, the transform, and more specifically the position of that transform. So that sets our destination to that waypoint. And we might say, but hey, we don't exactly have a check here to make sure that we're not hitting the end length, and that's totally right. So we'll say up here above all this, and its own separate thing here, we'll say if current point is greater than, and it doesn't really matter which one you pick because you have the same number of them, but we'll just say outside waypoints dot length. So if we're greater than the length of this, -1 obviously because arrays start at 0, and I'll explain why in just a second. But so if it's greater than the outside dot length -1, we're going to iterate up and go to current point plus plus monkeys. And if it's not, well, then we set current point equal to 0. And the reason we're doing length -1 is because arrays start at index 0 and our current point starts at index 0. So we're basing this off of, like, the first waypoint is index 0, second waypoint is index 1. That's how our code's working, but our length is just starts at 1. So a length of 5 waypoints is 5, but our last index in that is going to be 4. So we just need to subtract 1 here to make sure we're keeping our index length in line with our array indexes. So right up here we have, this is just a check to make sure we're not popping out of bounds in an array. If we get to the last waypoint, we reset to the first, and it starts looping through the lap. So we don't have to do that check in any of these scenarios. So if we're in position 1 through 3, we're selecting these waypoints where we're going to the most outside waypoint. If we're in position 4 through 6, we're in the middle, right? We're right where that AI wants it to be, so we need to select the middle waypoint. So actually, rather than type all that out, I'm just going to grab this, and we're just going to change one word in all of this. So right here where it says outside waypoints, we're just going to drop in middle waypoints. And similarly down here, right here where it says outside waypoints, we're just going to drop in inside waypoints. So if we're in 7th through 9th place, we're on the most inside track, we're trying to go faster. Well, let's take a look at Photoshop, and we see that there's not all that we wanted to do. We also wanted to have agent speed be affected by place. We talked about that earlier as a way of rubber banding. So here we can actually do that same thing. So when we're in first place, 1 through 3, we have the slowest agent speed. So let's do an agent dot speed. Hey, look at that, we can change that. And that is a float. So this needs to be a float value. We'll set this as 3.5f. And we can copy this, and if we're in 4 through 6, so we're in the middle ground here, we have a medium agent speed. Well, why don't we set this to 4.0? That's a 2. 4.0. And similarly, when we're in last place, we want to go faster. So the fastest agent speed we'll set to 4.5. So here, in this one function where we're iterating through, and we haven't even programmed our update yet. Don't worry that we haven't gotten to that. We'll get to that later. But in this one function, we have 2 rubber banding methods to make sure that this race stays compact and works together. We have various waypoints strewn across the race. So if we look at our race here, we have all these different waypoints, and if we're in first place, we're going to the most outside. So if we pretend that we are a race AI here, right? We're in first place, we've gotten to this waypoint right here, and it's calculating what our next waypoint is. Well, it's not going to be to this fastest one, right? That's saved for the people in last place. It's actually going to be coming to this most outside one. And since the curvature of the map dictates we're going to have to come here first, then here, and then at which point it then iterates and it calculates again, hey, what position are you in? Are you in first place? No, we're in the middle of the pack now. Well, then it goes to this middle waypoint, right? We're coming from here to this middle waypoint, calculates again. And now we're in third place, so we go to the outside waypoint. And this whole time we're calculating through our map, say, what are we doing? What is this? Now we're in last place, so we go to the inside track. Middle. And you get the point. So we're going through this race. Our AI is calculating where it is, based on its position relative to the other AI in the player. And it's changing its speed, and it's changing the waypoint that it's traveling to based off of that position. So like I said, we haven't programmed our update yet, and because a lot of that is going to be handling our position logic, and the position logic is actually pretty annoying. But we'll get to that next week. As of right now, this is going to be a really good spot for us to start and work our way up through our Race AI. Be on the lookout for episode 2 of this Race AI series next week. Really excited to do this one. As always, if this has helped at all, please feel free to like, comment, subscribe, all that jazz. It really does help us out. Check the link in the description below for a link to our Discord. We're always there. We have a really helpful help section. We have lots of people who like game design. We stream on Twitch. Some of our company people stream on Twitch. You should check that out. There's a link in the description below. And we have a game release, an app released on the Android store. So if you feel like giving that a look, you can find the link in the description below. I hope you guys enjoy this series. If you have any ideas for a future series or something like that where you might like to see something, let us know in the Discords or down below in the comments. And hopefully we'll see you next week.